Okay, so welcome into the lab, and the demo won't last long, so you can just watch it later, Nick. It'll only be about 5 or 10 minutes, but so this is our lab for Wednesday, and I want to demonstrate how to use the data that we've gotten so far. So here on the screen, you're going to see three different versions of of the um, the survey. And you can see they all look kind of similar, but they're all at wanky angles. I guess I need to. Which one am I? Oh, I'm on the wrong one. That's why. Okay. I was sharing a different wrong screen. Okay. There we go. So we've got. Whoa! Click. That fixed it. Okay. So you can see that this is about what one of those surveys looks like. This point over here was the corner of the building that was our known reference, and these were the 3 points along the wall of 309. But because everybody sets up a little different and their 0, 0, 0 on their azimuth is different, it ends up looking different all over the place. So we have to fix these up. Now, you're going to see later on how we determine this, but this line is fixed up at true north. And we happen to have been able to measure that this line actually does true north. If you look at the line of the thing, even if it's not, we can know that those all are lined up in the same direction. It just so happens that those are north. So I'm going to align those all first. ALIGN, enter, select my objects, enter, and then I pick a point on my object and then click a point and then a second point on my object and click a point, and it says, do I have a third point? No. And do I want to scale these? No. So there we go. And that's it. Now you can kind of see how that kind of matched up. And guess what else we know? We know that all of those points, this was our 0, 0 point, right? We said that's 0, 0. So I can go put that on 0, 0. Oop, what did I do there? Move from there to 0, 0. Oh, my dynamic is on. Darn it. Always make sure your dynamic is off. I hate that button. There it goes. And so we've got one. Now we want to compare the other ones to that. So that one is sort of our true. That's on 0, 0, which is where it's meant to be. And this is lined up with true north. Okay, so now let's take a look at it on the next one. ALIGN. Take my stuff and say this point goes here. This point lines up with this. I don't have a third point and I have no scale. And then I can move that from there. And now I can put it back down on there. And we'll see. So not perfect alignment, but pretty close, right? And that's what you would expect from different surveys, right? I mean, if they came out exact, I'd go cheater, cheater, pumpkin eater, right? And so now we'll do it on our third one. ALIGN. And this skill that we're doing here gets used in different ways later on. And so this is kind of just a nice simple way to be able to do it. And we're doing it with a comparison. And so as you get these all done, from the different ones, this is what I'm going to ask you to do and present in your portfolio. So you can see there, you could find the total difference that these are off, right? And just check it out. So what's my maximum deviation? DIST. My maximum to that point, as an example, is zero point 0.6 feet. So 0.3 feet would be, if I took the average of those, would be what you want to do. Or you can average, you know, this distance, and this distance, or however you want to do it. But it's kind of coming out pretty good. This is the main one that we want to get, and so, right, we want to know where those are, and you can see they're all lined up pretty parallel, but this green one seems to be off the most of the others. Okay, so you might even go, well, these two are awfully darn close, and maybe if there's two or three or four of them, you could maybe ignore this one. That's all statistics and all that kind of stuff. We're not going to worry about it. I want you to have that skill of what we call rectifying different surveys that are supposedly the same thing. We know that this known point was the same every time. We know that these were supposedly the same lines, all lined up the same every time. So we can go ahead and just do that, right? And then I made it as true north because I happen to know that it really is north. I mean, we've measured this I don't know how many times, and when we look at the building plans, it's north. That's where it was set up to be. And if you took your your setup with a compass and everything, depending on when it is, and you went back to when it was done and the azimuth of the change of magnetic north, blah, 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 you would find that's good enough for true north. Okay? So there we go. That's what I wanted to show. That is the lecture for today, and we're just going to go out and get more points now. Okay? So there we go. I'm going to stop the recording.